In the last video from chapter 2, that's really talk about combine everything we learned from chapter 1 and chapter 2. When we write a high-level language in the source file, like Java or C++, we got the user input. We run the program, then we display the output on the monitor. How that really happened? So in the input and output system, we can see actually we go over a couple different levels. When we write high-level language, we're using the C++ or Java. So those high-level language is portable, convenient, and friendly to the user. Even now, our computer hardware is really fast, but the high-level language is not always the fastest way to do that. But user-friendly, that's what we like to do. After you have using the high-level language to write the high-level language function, we want to get the user input or output. Actually, you need to go over the operating system. The operating system will have the application program interface that we call the API. So those API, for example, like your IDE, we write the C++ code from the IDE for the Visual Studio. From that application, one click, we can compile and run the program. So that's why for the application, they have extended capability, but they are actually coordinated by the operating system. You have a lot of detail you need to master. What does that mean? That means your operating system needs to allocate the memory space. Before you run the program, like earlier we showed you, when you run the program, you need to find where the program is. You need to know the program location and the file size. So then when we get the space, the spare memory to run, then we will allocate specific memory for that program to run. For the operating system, they will have the discrete table to manage those different processes. After the operating system communicates between the high-level language, then we can run to go to the from software to communicate to the hardware. So then that's really go to the BIOS. So the BIOS actually is the basic input and output system. We know we got the input from the keyboard. We got the output to the screen. But each one actually is the hardware connect to each other. So each hardware, they have the driver to communicate directly with the device. You may not feel you have the driver installed. Like the keyboard, you just plug in to use that. Your monitor, you just plug in to use that. However, that's because you already have your video card. So then video card have the driver installed to the software. So that's why they can communicate directly with the device. So then here, operating system, again, security may prevent application level code from working at this level. That's mean you cannot really direct access from those hardware level to control the hardware level code because that's a machine code. So they only can interpret using the operating system through the hardware to make sure they have the input and output. So then you can see here, if we have an example, when you write a high-level language program, no matter this one is C++ or Java, you just want to display a string of a character. Actually, they happen couple few steps. The first thing, your application program in high-level language. You write that statement, cout, that string. But cout actually is you have your library link to your compiler. But that's in the C++ level. But afterward, you need to interpret into the operating system function. Then operating system function will translate into the BIOS function. Then the hardware can display. So that you can see from level 2, between level 2 and the level 3, your library function, like for example, we say cout. So cout actually code the operating system function. You pass in a string pointer where that string location is. So then the operating system function using a loop to call a BIOS sub. So here it means subroutine. You pass it the ASCII code and the color of the character. Because one thing is, right, you know the ASCII code, which character you want to display. But also when you display on the monitor, you also need to know what kind of color or background color, foreground color you want to display. So that's actually came from the operating system function to code the BIOS subroutine. So then the subroutine will advance the cursor to the next position to the screen, so you know where you will display. So then when you get that character one by one, so the BIOS subroutine in the level 1, they will receive a character. They map it to a particular system font. So don't forget, right, we have specific font. ASCII table only tells us which letter to display, but how to display, usually they also have this particular font. Or if you don't have, we're just using the default. So then they send this character to the hardware port attached to the video controller card. So that's our hardware. So your monitor can see that that's because the video control card generates the timed hardware signal to the video display. So that's why they control the raster scanning and display the pixel. So your pixel will display on the screen. So that's why the same thing now, how you can see and view and read from your monitor. So that's why you see before in 110 or 165, or if you take 200, 210 class, we only focus on the high-level language. But to run the program, actually you need to pass each level one by one. Of course, we are not really care about the operating system function. We don't really use that. We don't really use the BIOS subroutine. We don't really see how the video control will use in this class. But actually each level, all the level we showed you earlier, the assembly language actually play an important role for each one. The assembly language actually perform input-output at each of the following level. Your library from your C++, we need to interpret into the assembly language so they can communicate with the operating system function. So then we need to communicate with the BIOS function. Then assembly language translate into the machine code, then the hardware will work. So that's why here, actually you can see assembly language actually is involved in all the level when we run from software to the hardware. So that's the introduction from our chapter 1 and chapter 2. So far, you can see we didn't really write any assembling code. So then from the next week in chapter 3, we will really show you how to start write assembling source file. And you need to have your Visual Studio 2019 ready on your Windows system, because in this class, we only using Mason on the Visual Studio on Windows system. So then we have the existing project you can download from the canvas. So then we will really implement the assembly language code.